Let me introduce to you another one application of perpetuity, which is capitalized cost. Capitalized cost is an application for perpetuity. It is one method used in comparing alternatives. It also defined as the sum of first cost and the present worth of perpetual maintenance and replacement. So we have three cases. Case 1, no replacement, only maintenance or operation every period. So for our capitalized cost, we have capitalized cost equals to first cost plus present worth of perpetual operation and or maintenance, where FC is the first cost or initial investment and POM, P and M is equal to the present worth of our perpetual operation and maintenance cost. Then case 2, replacement only, no maintenance and or operation. So capitalized cost is equals to first cost plus present worth of perpetual replacement. Or the amount needed for replacement is S equals to FC plus minus SB. S is equal to FC minus SB, or first cost minus the salvage value. Then case 3, replacement, maintenance, and or operation every period. So our capitalized cost is equal to first cost plus the present worth of cost of perpetual operation and or maintenance, and the present worth of cost of perpetual replacement. Example, determine the capitalized cost of a structure that requires an initial investment of 10 million pesos and an annual maintenance of 950,000 with I equals to 15%. So here, the given is the initial investment, 10 million, and annual maintenance. As long as the structure is there, then you need to spend an annual maintenance of 950,000. So for our cash flow, then you have a perpetual obligation of annual maintenance of 950,000. So our present value is equal to A over I, or 950,000 over the interest, which is 0.15. Or you have 6,333,334 pesos. Then our capitalized cost is equals to first cost plus our perpetual maintenance. Then you have 10 million plus 6,333,334 pesos, or our capitalized cost is equals to 16,333,334 pesos. So for our next example, a new engine was installed by a textile plant at a cost of 300,000 and projected to have a useful life of 15 years. At the end of its useful life, it is estimated to have a salvage value of 30,000. Determine its capitalized cost if interest is 18% compounded annually. So here's our cash flow. So first, you have an initial investment of 300,000 for your new engine. At the end of 15 years, you have a salvage value of 30,000, and then you buy another engine for 300,000. Then same for the next 15 years and the next 15 years. So since you have a salvage value of 30,000 every 15 years, so the money that you will spend every 15 years is only 270,000 every 15 years due to the salvage value of 30,000. So our x is equal to s over 1 plus I raised to the power of k minus 1. So our value now of s is equal to 270,000 over 1 plus 0.18, which is our interest, raised to the power of 15 minus 1. Or we have x, the present value of our replacement equals to 24,604.17 pesos. So capitalized cost is equal to first cost plus X. Then we have 300,000 plus 24,604.17. We have a capitalized cost of 324,604.17 pesos. So here, it falls under case 2. Since you have what? You have only replacement. So case 1 is operation, then case 2 is replacement. So you replace your engine every 15 years. Our next problem, or example, determine the capitalized cost of research laboratory which requires 5 million for original construction, 100,000 at the end of every year for the first 6 years, and then 120,000 each year thereafter for operating expenses, and 500,000 every 5 years for replacement of equipment with an interest of 12% per annum. So in this problem, it falls under case 3. You have an operating expenses plus a replacement. So for our operating expenses, so the present value of our operating expenses. So for the first 6 years, you spend 100,000 every year, and then after 6 years, you spend 102,000 every year thereafter. So the present value of our 100,000 for 6 years plus the present value of our 120,000 thereafter is equal to your present worth of cost of perpetual operation. So you have P is equal to 100,000. So simple ordinary annuity. And then we have the deferred annuity using 100. So here we use the perpetuity formula. So perpetuity, then the present value of our 120,000. So our present worth of our cost of perpetual operation, then we have 917,740 pesos. So next is for the replacement. So for the replacement, you replace every 5 years an amount of 500,000 for your equipment or laboratory equipment. So let X be the present worth of cost of perpetual replacement. So X equals to S, which is 500,000, since there is no salvage value of your equipment after 5 years. So you have 500,000 over 1 plus 0.12 raised to the power of 5 minus 1. Or you have a perpetual replacement every 5 years of 655,000. So the present value of your replacement every 5 years of 655,873.88. So for our capitalized costs, you have first cost plus perpetual operation plus the perpetual replacement, which is equals to 5 million, which is our initial investment, our initial cost, plus 917,740, which is the perpetual operation, plus the perpetual replacement, which is 655,873.88 pesos. Our capitalized cost is equals to 6,573,613.88 pesos.